All right, so we got Unit 7, Lesson 8, Rewriting Quadratic Expressions in Factored Form, Part 3. So we start off with asking, can products, again, product in terms of math is multiplication, be written as differences, basically subtraction, right? So let's find out. Claire basically asks, can 10 plus 3 times 10 minus 7 be equivalent to just saying 10 squared minus 3 squared? She also asks about 20 plus 1 times 20 minus 1 being the same as just 20 squared minus 1 squared. All right, so I will do the first one, and it's up to you to do the second one. That was supposed to be a star, but now it's a kite. All right, so let's look. So if you take Claire's situation and we think of it like when we were distributing the binomials, right? The distributive property basically says this 10 is going to multiply to that 10, and it's also going to multiply to this 3. In that process, you do get 10 times 10, and 10 is multiplying to that negative 3. If you distribute the 3 to both of those terms on the other part over there, you get positive 3 is going to multiply to a positive 10, and you're going to get a positive 3 multiplying to a negative 3. Now, 10 times 10 is 10 squared, yeah? And if you notice, the 10 times the negative 3 gives you negative 30, which will cancel out with a positive 30 over here. And the negative symbol can move over there, and you do have two 3's multiplying to each other, which is the same as saying 3 squared, okay? If you do 3 times negative 3, you get negative 9. And if you do the 3 squared and then apply the negative, it's the same as negative 9. So this would actually work with Claire's theory. So in this situation, Claire is very, very on the mark for this one. So go ahead and try the 20 minus 1 or plus 1 times the 20 minus 1 and see if it comes out to that using very similar structure in which I used a distributive property. Okay, so number 2, you're doing the same thing as you did with 20 plus 1 times 20 minus 1, except it's for this situation. Okay, and you could always double check by computing your answer right here. All right, so number 3, is x plus 4 times x minus 4 equivalent to x squared minus 4 squared? Support your answer. So with the diagram, we know that x times x happens when you distribute the x over here. You get x squared. When you distribute the x to this negative 4, you get negative 4x, right there. And when you distribute the 4 to both of those terms, you get 4x. And 4 times the negative 4 is negative 16. Notice how the x values right here and here cancel each other out. All that would be left is x squared minus 16, which is actually the same as up there. So yes, they are equivalent. Without a diagram, I would just use the distributive property. We got, again, the original situation, the binomial x plus 4 times the other binomial x minus 4. And you use the distributive property, just like how we did earlier. You get x times x, and x times the negative 4. And the 4 distributes, so 4 times the x, and the 4 times the negative 4. you end up getting x squared, negative 4x, positive 4x, and the negative 16. The x's, just like with the diagram to the left, canceled out, and you'll get the same result. So yes, these would be equivalent. All right, number 4 is definitely for you. Okay, is x plus 4 squared, the whole thing squared, equivalent to x squared plus 4 squared? So remember, this is the same as saying x plus 4 times itself x plus 4. So go ahead and see if you get this, and make sure you support your answer. You could use the diagram or without a diagram. It's really up to you and where your comfort level is. Right, so what if there is no linear term? So each row has a pair of equivalent expressions. Oh, fun. So we're basically just completing the table, yeah? So you could use the distributive property, right? If we're going from factored form to standard form. We got x times x, that's x squared. Then you got x times 10, which is just 10x. The negative 10 times the x is negative 10x. And the negative 10 times the positive 10 is negative 100. Notice how the x values here cancel out. So all you actually have is x squared minus 100. And this kind of comes back to the conversation we had earlier, because this would be the same as saying this, right? So just be aware of that. So this one, that's for you, right? This one, that's for you as well. Oh, going backwards. So notice how there's no middle term. There's no some number with x. It's just x squared and negative 81. All right. So how can we get that into something like this, into factored form? We know x times x gives us x squared. What two same numbers give you 81? We know 9 times 9, right? But notice how there's no x value in the middle. That means one of these 9s is negative, while the other one is positive. Because if you actually FOIL that, if you distribute, shouldn't have said FOILed, the math gods will strike me down. X times x is x squared. X times 9x is 9x. Negative 9 times positive x is negative 9x. And negative 9 times positive 9 is a negative 81. But do you notice how the x terms cancel out? And that's why there is no 9x, right? So that basically takes care of that. Go ahead, try this one. This one's for you. And just be aware that you're dealing with y, right? And 49. You're definitely going to have something like this, yeah? But what two same numbers give you 49? All right, so hopefully you try that one out. And you get something like this, right? But there's a problem. What's the problem? There is no y term, right? You see that? So one of these does have to be positive, while one of them has to be negative. But if we do that, how do they get a positive 49 here? So I want you to try to figure that out, all right? I don't want to give you everything, but it's a good head start. All right, let's try this one. All right, we know 3 times 3 gives us 9, right? 3 squared. And we know 16 is 4 squared, right? So let's see here. We're definitely dealing with z. So if we do 3z times a 3z, does that give us 9 z squared? It should, right? But notice there's no middle term. And that's because one of these is negative while the other one has to be positive. And it's 4, right? 4 squared. That would work. Okay, you could always test it by distributing it and seeing if it works. Go ahead and try this one. It's a very good one. Highly recommend that one. It's very similar to that. Okay. The next one is a bit silly. It tries to throw out fractions to confuse you, but don't freak out because it's the same rule. You got c times c, it's just c squared. But notice how the last part of your binomials is the opposite of one another. So there's no middle term. So what's negative 2/5 times positive 2/5? And you should get negative 4/25. Okay. Definitely try this one. It's a good one. All right. It's a very good one. Some interesting fractions there. We already know what 49, what two of the same numbers gives us 49, and two of the same numbers gives us 16. So think perfect squares. This one is an oldie, but a goodie. You've done these ones already, so just distribute and go the other way with it. This one is much more difficult. Is -6 a perfect square? No. So with this situation, it's not going to be pretty. So we know x times x. We know that this has to be negative and this has to be positive because there's no middle term. There's no some number with x. And we just have that constant in the -6. So if you do negative square root of 6 times positive square root of 6, what's the square root of 6 times the square root of 6? Okay, you should just get 6. So negative times positive, negative, -6. So that one was a little tricky. We had to use square roots there. So if you remember square roots, square root of 36 is either positive or -6, right? So just be aware of square roots and how those work. The next one is a very nice one. Actually, no, it's not. It has a symbol issue. So try that one. It's a challenging one, but it's a good one to mull over. I do tutoring on Wednesday, so if you get stuck on that one, just drop by on Wednesday. All right, that's the end of this lesson. Have a beautiful day. Bye.